Thank you all for coming this afternoon and participating with Don and myself in this engagement of democracy and technology, and I really do thank all the organizers for setting this up. This debate is not about only the Marcellus shale play in New York State. It's about all unconventional plays using high-volume fracturing in New York State. This debate is not about only fracking and water. It is about everything that comes before fracking and everything that comes after. And this debate is not just about one frac stage, on one well, on one pad. It's about the cumulative impacts of hundreds of thousands of the events that Don just described. Not one, hundreds of thousands. So this debate is about all the impacts that unconventional gas development from shales in New York State might have. So I'm going to divide my comments over the next few minutes into four categories. First, I'm going to concentrate on the predicted scope of the development. How many frac stages on how many wells on how many pads? Big. Bigger than, I think, what Don just suggested we might be anticipating. Next, what have we learned from other shale developments in other states? What are the best management practices? What are the violations? What is the risk? Data, facts. Next, what are the effects potentially on existing businesses? We've all heard what the possible bright side of development is. Jobs, taxes, wealth. Very few people talk about the downsides. Nobody in this room believes in the silver bullet. And finally, the biggest impact of all, which Don alluded to right at the very end of his talk, and he and I are in complete agreement on this. Yes, global warming is real. The greenhouse gas emissions from high impact, immediate, intense development of gas from unconventional sources will have an effect on climate change. Therefore, will have an effect on our kids and our grandkids. So let me begin. First, scope. Let's make sure we all understand what we're talking about. A conventional New York State gas well, like the 50,000 or so that have been drilled in New York State for the last 150 years, one pad means a well means less than 80,000 gallons of fracturing fluid and therefore less than 80,000 gallons of waste. That's the past. The average unconventional shale gas well in Pennsylvania right now, the average one, a pad is up to 8 wells. Each well is using up to 10 frac stages, and therefore cumulatively in one pad they're consuming 44 million gallons of frac fluid and producing millions of gallons of frac waste. Professor Engelbert, the father of Marcellus shale, everybody acknowledges that, estimates that the New York State build-out, low end and high end, what we can expect in New York State for the Marcellus alone, not including Utica and all the other shale formations that could be drilled and developed in New York State, 36,000 to 78,000 wells. At an average of 10 frac stages per well, which is the current average in Pennsylvania, that's 360,000 to 780,000 frac stages, each of which will use about 500,000 gallons of frac fluid and produce a concomitant amount of frac waste. Let me emphasize the last point on this slide by reading it 3 times. The first 1,000 shale gas wells unconventionally developed in New York State will consume more fluid and produce more waste than all the gas wells ever drilled in New York State. I'm really not going to read it 2 more times, you can. But I think you got the point. We're talking 2 orders of magnitude larger activity here on a well. One has to ask, what does that mean? What will be the effects of that cumulative impact? Because no one knows yet. The oldest unconventional shale gas well in Pennsylvania, the Marcellus production, is 4 years old. We have seen the tip of the iceberg in Pennsylvania, 2,340 Marcellus wells drilled to date, 1,112 producing gas, therefore hydrofracked. Pennsylvania assumes somewhere between 100 and 200,000 wells. They don't know what the future looks like. We can only guess, and I'm here to help you guess. Again, impact. Don mentioned Dimick. I'm not going to spend a lot of time talking about Dimick except to point out that it was a god-awful experiment. And there's absolutely nothing in regulation in New York State today, since New York State, as we sit here, has 0 regulations regarding unconventional shale gas development. We do not have any regulations. ECL 23, which is the only set of regulations currently on the book, because the SGEIS is still in development, ECL 23 says absolutely nothing about unconventional shale gas development. So what happened in Dimmock is clearly shown in this slide. There's 9 square miles, small village of Dimmock. Every one of those blue things is a pad. Remember, a pad no longer means one well. A pad no longer means 80,000 gallons. A pad means multiple wells. A pad means millions of gallons of fluid. The more fluid you have, the higher the risk that everything before that fluid gets to the well, while the fluid is going down the well, while it comes back up, and until it gets disposed, those risks go up. So this doesn't look like one pad per square mile. That's not what happened in Dimmock. So let's project forward what we'd all like to see. We'd all like to go into the future at some point and say, what would Vera around Cortland look like 5 or 10 years from now? Well, let's take 2 extremes. Let's take the current extreme, which is ECL 23 says you want to drill a well? Drill a well. You got 40 acres to do it on. So there's 9 square miles. We're sitting right here, I believe, right now, near downtown Cortland. There's the equivalent of the 9 square miles around Dimmock. That's the number of pads you would expect to see. Now, that's not where the industry is going. Don's right, the industry keeps evolving. Let me show you what they're evolving towards. And if you think it's going to look better than that, think again. Here's the first large-scale experiment that was actually performed in the Barnett Shale in Texas. Over the last 3 years, one developer, Chesapeake, got permission from one landowner, the city of Dallas-Fort Worth, to develop the Dallas-Fort Worth Airport as a gas production zone. This is a map of the Dallas-Fort Worth Airport. On that airport grounds, they put 53 pads and drilled about 300 wells. Notice the density of the wells. Each red line is a well, almost complete coverage. This was an experiment. We in New York, we do have something that's on the books. It's called compulsory integration. Compulsory integration means there is nothing legally stopping a gas company from doing that to you. They don't have to have one landowner that agrees. They don't even have to have one company agreeing with one landowner. Compulsory integration means they can get the gas wherever they want, however they want. More proof, northeastern British Columbia. This is where all the experiments are actually being done by the gas industry. There's no very few people up there, not too many regulators, northeastern British Columbia. Here's another example of where the technology is going, and this is what we can expect to see as the industry develops best production practices. Each one of these lines, again, is a well. Here's a pad. Notice in some of these cases there are 16 wells coming off of a pad. So yes, you're going to have fewer pads. But it's not the number of pads that's important. It's the number of frac stages per well. Each frac stage requires about 500,000 gallons of fluid. The more frac stages you have, the longer the lateral well. The more wells you have per pad, you do the math. So it's a chimera to say that we're having fewer pads, therefore less impact. So where is the industry right now? Here's the second largest frac job ever done in the world, early 2010. Does it look like what you see in the pictures around here with just one little operation in the middle of a cornfield? That's not the biggest operation. Here's the biggest one. That's a 1 square kilometer pad. 16 wells, read the numbers. This is where the industry is heading because this leads to higher productivity at lower cost.